If you wouldn't like to be part of the recording, this will be made available on the Fair Impact website. Simply keep your video off for the duration of this call, or let me or one of the team know. So welcome to today's Fair Implementation Workshop, this week focusing on the Hungarian Research Network's Research Data Repository platform. So our Fair Implementation Workshop series aims to help 3 key stakeholders: research performing organizations, repositories and data service providers, and national level initiatives to become more familiar with FAIR enabling tools, approaches, and methods. Each workshop will provide an overview of a specific FAIR enabling activity, share information on recent developments, both from within FAIR Impact and other initiatives, as well as offering examples of good practice, practical tips, and recommendations. Just a little bit about the FAIR Impact project itself. So the FAIR Impact project is funded under the European Commission Horizon Europe program and is one of the Infra-EOS projects. The project builds on the work of the Horizon 2020 FAIR project and is a coordination and support action focusing on expanding FAIR solutions in Europe. The project began back in June 2022 and will finish next month in May 2025 and is made up of 28 partners from 10 member states and the UK. So the FAIR Impact project is working to support the vision of a European open science cloud where FAIR data can be shared and reused. Our work focuses on identifying current and emerging tools, methods, and approaches, supporting their adoption. A key aim for us is to ensure that useful resources developed by one community of practice can be adopted by others. And that leads us nicely on to introducing our members today. So at this point, I'm going to hand over to Laszlo, who will perform the introduction to the platform. Laszlo, I'll stop sharing my screen and hand over to yourself.
Thank you very much. I try to share my screen. Okay. And start the presentation. Is it visible now?
Yes, I can see that now, Laszlo.
Okay, thank you very much for inviting us. We try to introduce this Hungarian Research Data Repository platform under the umbrella of the Hungarian Research Network. We are coming from STACI, the Research Institute for Computer Science and Control in Budapest. And inside STACI, we represent the DSD department, the Department of Distributed Systems. The Research Institute was under the umbrella of the Hungarian Academy of Sciences previously, but currently this is a Hungarian Research Network, is a completely independent organization. In the DSD department, we were quite active in the European research arena in the digital libraries and repository system domain, as well as in the collaborative systems. So that's why it's obvious that this project was carried out by us. What is ARP? ARP is a national research repository, a data repository platform. We built it together with other institutions. The idea is to really provide different services for all of the disciplines practiced in Hungary, and help researchers to share and publish their research data and the associated metadata. The network itself is a large organization consisting of 50 different research institutes organized in research centers, independent research institutes, and research groups affiliated with universities. And the idea is really to do basic and applied research in these domains. Just to show that our institute, the STACI, is an independent research institute within the network, and the centers are hosting many other institutes. The Hungarian research arena is equipped with basic national services. Some of them were developed by us, directly the DSD department or STACI as a whole. The very first is the Hungarian National CREST system called MTMT. Also, the HUN-REN Cloud and HUN-REN ARP were developed by us. And previously, the Federated Full-Text Repository Network was developed by DSD. Supercomputer network is also can be considered as a national service. Those are discipline-agnostic services. What are the main characteristics of ARP? It's a central repository platform, a set of services for the institutes. Basically, it's a federation of existing and future data repositories. We also provide central data store facility and the single metadata schema service for the whole country. And this is a way how to try to achieve the semantic interoperability, at least within the country. The idea is to provide mid-term preservation for research data. Mid-term in the meaning with 5 to 10 years long period. Long-term preservation is not yet available in our country. The idea of ARP is guided by the open science and fair principles, of course, and we are targeting the EOSC Federation as well. But as we started earlier, then EOSC tools and core services were available. That's why we integrated existing production level tools in order to achieve the high TRL levels. Besides the normal services, we provide all other services such as teaching and training programs for the fairs, the open science principles and policies, and of course the ARP services. Organize the ARP ambassador program among the researchers, and the HUN-REN network started a data steward program in which all institutions will be equipped with data stewards to help the researchers to handling the data, research data. One of our tasks is policy crafting, which means that we help to formulate the different policies in different levels, in the institutional level as well as in the umbrella level. The development started almost 5 years ago because we had several unsuccessful proposals. But after the acceptance, there was a 2 years long period for software development. Also, we set up the hardware environment in the center, which is a 1 petabyte, bigger than 1 petabyte store in 2 independent locations with triple redundancy and magnetic tape background. And we opened the system last year, especially at the end of last year was the official opening. What are the core components? Similar to EOSC, we provide the core services for the network. It's consisting of a data repository, the central store facility based on the DataVerse software, a centralized schema registry based on CEDAR. In the center, there is a knowledge graph which store the metadata records of the whole network based on a Vivo environment. And on the top, we developed a unified search facility for the whole network. And also, we decided to use the AROCREAT format in order to handle data sets uniformly. The components we used within this integration were developed by different universities, well-known software pieces, Harvard DataVerse, Stanford CEDAR. Also, they have an Ontoportal module. The knowledge graph was based on Vivo, but Stucky developed the remaining 2 other integrated components for harvesting purpose and search purpose, and also the AROCREAT manager was developed by Stucky based on this original Describo piece, software piece. The iTouch is quite complex because we had to handle metadata using the an ontology registry, the schema registry, and the error crate management environment. The data is stored in a central store facility and also in a knowledge graph. And then on top on the knowledge graph, we offer this kind of search facility. The other components are really managing the network, the federated network. We harvest those repositories, and of course we try to, in the later run, we try to monitor and control them remotely. These are the main feature sets of ARP, but this is not the end, because after the first phase of development, we try to start a new development phase and build a kind of FDO-conform middleware. The middleware idea is really to provide an object-based environment for research infrastructures of the country, and this object-based environment will probably use ARO crate profiles in order to pack everything what are needed for data handling. These ARO crate profiles assumes that there is a ARO crate profile registry. Unfortunately, currently it's not available in Europe. So, dependent on the availability, we will develop that facility or expect a service from outside. But besides that, similarly to the MSCR component of EOSC, we have to provide a crosswalk registry or crosswalk facility in this middleware. Besides the different data conversion facilities planned within this middleware. But we are not going to stop there, because additional high-level services will be planned. And the very first is the electronic lab note service, which is required by those researchers who are intensively use lab activities. And also the data management plan and domain and the executable data management plan idea is in our focus nowadays. The most problematic part for us really is how to connect this whole environment to EOSC. Because what we learned currently, that the EOSC is not yet providing production level services in Europe. And that's why we are in a big trouble, because the whole original idea of ARP is really provide immediate services in the production level. That's why there is a big question mark how to connect this environment to EOSC, but we try to understand the different movements within EOSC and the available tools, and evaluate them, and try to understand the concepts and the tool features, and we will see what to do in the longer run. So this is a short introduction of the ARP system. So I give the floor to Balázs to present how we integrated those components. I will stop my share.
Okay, thank you very much. So I will share my screen now. Okay, I hope you can see this. So as László introduced, we have a couple of components that I would like to show you, and how we integrated all these to make metadata authoring easier for all disciplines or scientific disciplines of the Hungarian research community. So first of all, we have, as László mentioned, we have an installation of Dataverse. So this is, as you might already know, is for storing data sets with files and describe them with metadata. Then we have a CEDAR-based schema registry. CEDAR itself provides a metadata authoring tool. So if I just open the default citation metadata that is also available in Dataverse, it provides a visual editor, a drag and drop user interface for defining the various metadata fields and all their attributes, like whether it is required or can be a multiple of it, and things like that. The nice thing about the CEDAR is that it is connected to OntoPortal, specifically to BioPortal, which provides it with ontologies and controlled vocabularies. So whenever we author the schemas, we can, from CEDAR itself, can go and grab terms from OntoPortal. For example, the usual Dublin core properties are all available here, and we can grab their URIs via CEDAR. And the last piece of the puzzle we have here is this federated search environment. I will just show you a little bit of it, and András will talk more about this later. So the way I would like to present how these work together and how we enable a more richer metadata authoring is that I will now be a paleontologist who wants to create a new data set, and I will show you what problems someone might face with Dataverse. So first of all, when I try to create my data set, it will be about dinosaurs, interesting dinosaurs, and I will have to fill all the required fields, which are marked with the stars. I will not really go into details of this, just very simple description here because it's required. And I have to specify a subject of my research. Unfortunately, paleontology is not here, so I will just leave it as other for now. And yeah, I could fill all these others, but for the time being, I will just add my files. I have a well created set of dinosaur pictures with nice pictures. And so I would like to add metadata to my data sets. The first problem is that once it is saved, and hopefully it will be, unless this is the usual demo effect when it doesn't work. Although it always does. Okay. That makes it difficult for me, yeah. I will try again. And I will try with the data upload. Okay, we have missing fields. So this will be simple here. And I will have a subject. And it doesn't want to help me with this issue. Okay, anyway, the problem that I would face here, I may go to another data set here, is that when I create my data set and assume that now I have all these dinosaurs here, the problem is that I have only a limited set of metadata options in Dataverse. These are called metadata blocks, and these are predefined, and I could add some geospatial metadata I could add some social science metadata here, but there is no paleontology related metadata. So I could not define whether my data set is about vertebrate or invertebrate species of dinosaurs. And this is where the schema registry and schema authoring tool comes into pictures. If you are familiar with the Fair Impact created tools, this is very much like the data type registry combined with the MSCR, the metadata schema registry. So here we can create new schemas. First, I will create a directory for this. Metadata, yeah. And here I very simply can create a template. It is called a template. I have to provide a name, an identifier. And I can now select the different kinds of input elements I want to use. For this, I will use a radio button. And this will be called the paleontology branch. This will be actually the label. The field name cannot contain spaces, so it will be like this. And I will have two options that the user will be able to select, whether it's a vertebrate or invertebrate species. So if I try to save this, I will get an error here saying that the term URI must be specified here. So this is very important that all fields will be semantically specified by a URI, which I can provide here. And this is the part where it goes out to Ontoportal, specifically to Bioportal, by looking up the name of the field I want to use, and it will look up similar sounding or looking properties, and I could select one here, which would be used as my URI. But as we don't have this now for this demo, I will just provide the URI by hand, very simple, and it doesn't really matter for now. But to make it complete, I have to provide a URI. And once I did this, we have this button to export to Dataverse, which makes this schema available as a metadata block in Dataverse itself. And from now on, if this part works, if I reload my metadata authoring page here, then beside the citation metadata, the paleontology metadata we just defined appears here. And here I can define that this is a data set of vertebrate dinosaurs. And here we have more problems with data set. And in the meantime, it turned out that it worked here and it finally uploaded. Okay, then I can go here and add actually my metadata that I wanted in the first place. Okay, and it works now. So we have here my files in directories, and I can take a look at each individual file. And one problem that we met in Dataverse that there's just very little metadata available for files themselves, like the name and MD5 hash and things like that. So there is no real way to describe, besides the data set itself, the individual files, which would be very important in case of measurements, for example. What was the setting of an equipment which produced this data and things like that. But to overcome this, we added to Dataverse full support for ARO-crates, because ARO-crate is a format which allows expressing more richer metadata than is available in Dataverse itself. So we have this AROMA tool, which is available for our data sets. And if I open this, and I maybe create two windows here so you can see them side by side. So in this AROMA tool, we have exactly the same data available as in Dataverse. You can see here the actual files, the same files we have in Dataverse, in the same structure, and we actually have the same metadata as well that is available in Dataverse. So if we look at the citation metadata here, like we have this interesting dinosaurs title here. Here in the citation tab, we have the same data as well. So actually these steps here match the metadata blocks of Dataverse. And also these are the schemas that come from CEDAR, our central schema registry. So here's, for example, the paleontology data we just added. And these two words, the Dataverse word and the ARO-create word, are synchronized. So if I edit, for example, here the title of the data set and save it, then it hopefully will also update in my AROMA ARO-create editor. So ARO-create itself, as you probably know, is a JSON LD format which describes the files and the whole structure of the data set, and you can define metadata for the data set itself and the files themselves as well. And the synchronization here works backwards. So if I edit in AROMA as ARO-create, then the Dataverse data should be, if I save it, the Dataverse data should be updated as well with this title. So as we now have this complete synchronization of Dataverse data and ARO-create data, we went one step further, and we wanted to add the possibility to add metadata at the file level as well. To do this, we also use the ARP Schema Registry, but this time we don't define a Dataverse level metadata block. Rather, we define a file schema, as we call. And let's say that for each file, I want to define a couple of data items, and we call it just Dino metadata. For example, I have no way to actually, as you see, I just have here Dino11 JPEG, and this is not really descriptive of what kind of dinosaur this is. So first of all, I need a dino type where I can actually define what kind of dinosaur we are talking here. I will add just a demo URI here. It doesn't matter for now. And this will be just a simple text. I don't need any other options. Then maybe I want to add some information about which continent this dinosaur lived. For this, again, I can define a continent field. I can add a label. But this time, I will try to use the help of the bioportal. So I already know that the RCD ontology has a continents. I know. Oh no! Sorry. That's not what I wanted this time. Okay, I wanted to have to show you the controlled vocabularies this time, so that I can define a field and have the values of this field selectable by the user to come from the bioportal. But the method is the same. I look up the name of the class I'm interested in, and actually I found here this RCD class. I can even see the details of where this term occurs in this huge ontology. And if I see that it fits my needs, like it defines all the continents I need, then I just simply have to add this to my definition. So I defined a continent which provides controlled vocabulary coming from OntoPortal. And yeah, the URI I still need to provide here. As I started, okay, the continent, great. Okay, and let's say that this would be enough for my files to describe them in more details. So if I now go back to AROMA, as you see here, we have a metadata schemas section where I can add by selecting any data or any file or sub data set. I can select schemas. This actually browses the same data that is contained in the schema registry. And here's our Dino metadata. And if I add this to AROMA now, then you can see that it appears as a tab here. And right now I can finally define that this is a Tyrannosaurus Rex, and it lived in North America. Great. So what I could achieve here, that although Dataverse didn't allow that much metadata associated with files via AROMA, I can associate these files, these data, even defining my own data schema for this. So if I go back to my files, to this Dino 11 in Dataverse, of course, in the Dataverse stored metadata, you cannot see this, but here we also have an AROMA tab. And if I go here, then it will show the data I just authored there. And this data is stored in the associated ARO-crate metadata JSON along with the files. So once I'm done with my data set, I can, first of all, I can download it as ARO-crate. All our data sets are exported as ARO-crate, and we can also import ARO-crates. So we can move data between even Dataverse installations. If I download this data set, it conforms to the actual ARO-crate requirements. It has all the files in it. It has a ARO-crate metadata JSON, and it has an HTML preview, which allows some visual representation of all the metadata that we associated. So if I go to Dino 11 JPEG, then you actually can see the Dino type and the continent information we just added here. Finally, if I go back and if I'm satisfied with my data set, it now has all the data that I wanted it to have. I can now publish the data set. Publishing the data set will generate a permanent identifier. We have handles in our system. And the published data set should be then available in our ARP search engine. This is the knowledge graph based search engine that András will talk about later in a couple of minutes. The publication of the dataset may take some time, but hopefully it will finish. What it will allow us, for example, here, if I try to search for Tyrannosaurus Rex, it would not work because this data is just associated to a file that Dataverse itself is not aware of. But if we are in luck and this dataset gets published, then the effect would be that in our search engine, which collects data from our Dataverse and from other sources, I could look up my Tyrannosaurus Rex file via this search mechanism as well. Yeah, it currently did not finish. This is now one of those demo days when nothing wants to go smooth. Anyway, I think I will pass it on to András to talk about our search engine, and hopefully in the meantime, my dataset will be published and I can show you how it looks in the federated search tool. Okay, pass it on to you, András.
Okay, thanks. I'm sharing my screen. Okay, so I will, in this architecture, I will talk about the green and the red parts, the knowledge graph and the federated search. But first, a little bit of explanation is needed, how it is built up. Yes, so we are doing a little bit of harvesting, which means that we are connected with currently 4 data repositories. First one from the left is our own data repository, and then there is a social science data repository, and there is a data repository from University of Debrecen. It's a nearby town in Hungary, and of course Zenodo, the big European data repository. And you see that we are collecting, we have different formats available on all these sites. So of course we exploit this ARO-Crate functionality by our own Dataverse. But for example, from the Center for Social Sciences, we get only RDF XML, and we have JSON harvest data from the other 2 repositories. So we need our own code to handle all these scenarios, and this goes on. These are collected, and then we have the schemas imported from the schema registry. So we all have the different schemas for the different dialects of these repositories. And we convert it to linked data. Specifically here it is RDF, the basic language of the semantic web. And it is the next step is very important, the entity matching, where we need to deduplicate and correlate all these entities. Think about the user names, the author names, or we have a big trouble with the institute names because they are always written in 100 different formats. So we are using ORCID for persons, ROR for institutes, and of course we are using DOIs when it is available. Based on these persistent identifiers, we try to singularize or deduplicate these R entities. And then finally, this all goes into the linked data store, which is the famous Apache Jena RDF store. So this is the harvesting part. And then, what is in the linked data model? This is a kind of simplified model. We have the main entities here, the dataset, files, of course, files are inside the dataset. We have topics, and we have authors and institutes, but what is most important is that we have the schema elements also coming with the ARO-Crate or coming with the different setups of the different repositories. These are all integrated into the model. And then as we have this unified model, we have 2 types of search. We have a simple search, and it is based on a straightforward Solr indexing. And we have the advanced search where we can use the schemas coming from the schema registry, and these queries are converted to Sparkle, which is a query language for triple stores, and then they are executed, and I will show you how this works now. So yes, so this is the search platform and the knowledge graph platform. So here in the middle, you see the simple search facility. You can also select what kind of objects or entities you want to search for. And here you see all the various assets in the model. let's start, for example, with our data sets. You see that here are the different repositories and the number of data sets from each repository, and then you can browse into one data set, and you see all the data. You see the files here. You can go navigate to find the files. This is a folder here, and you have the simulation folder, or you have an EPS data file, and from there you can go directly to the file itself, coming for the research center from physics. Let me go to the schemas part. Here you see all the schemas coming from the schema repository, the CEDAR repository. And here you see that we are experimenting with new schemas, not coming from Dataverse, but coming from our own researchers. For example, a folklore schema and a hydrogeochemistry schema. For this hydrogeochemistry schema, I show you that this is a data set using this schema. Here you see the various schemas. So if you see the basic model schema, then it's just persistent identifier and description and repository and license and so on. But if you go to the geospatial schema, that you see that this is from the Valencia Hills regions, and you see the geographic bounding box as well. And there is this special new schema which covers various chemical things like measured major ions and measured trace elements and so on. Of course, you can select to view all these metadata fields at the same time. And here we have institutes, for example, and if you go to an institute, then you see the authors coming from that institute, and then from this, if you go to an author, then you see the various data sets. So here is an example data set from this author. So far, so good. What I haven't shown the search facilities. So let's start, for example, with this name, which means wolf in Hungarian. So it's a quite common surname. And if you see, here we have various types of results. We have data sets, keywords, authors, and citations. So we can filter for the keywords, and we see now this is the keyword is Little Red Riding Hood, as the famous or well-known tale, as given as a keyword here. But also we see authors and data sets. What happens if I go for search for laser? Then we have data sets for lasers, dealing with laser, and we see that these are one is from Zenodo, and the other is from another two is from ARP. So this is the simple search facility, and I prepared search because it's a slower process. So first you can decide for what type of objects you want to search for at stay with dataset, and then you select the schemas similarly. So as we have done, as you've seen in the AROMA editor. So it is the same process. And then if you selected your schemas, then you can select the metadata fields you want to use. So for example, here, let's search for a typical first name, just for the demo example. And then you see the results, and then you see the result distribution around among repositories, or you can see the year distribution, the topics, and the authors as well. And of course, you can go straight to the download page of the selected item. But let's change this to this new schema. This so I want to search for major ions. It's simple. Second demo effect. So what happened here? Anyway, we saw 10 minutes ago this worked. It's before. Okay, let's stay with this basic search and so I think this here I can end this demonstration. This was the last part, the advanced query facility.
Okay, I can maybe show because mine just succeeded. So if you let me share my screen. So we left off that we published the dataset, and this, because it has been published, it became available in the search interface. So if I'm searching for Tyrannosaurus Rex or Tyranno, then the file that we actually added metadata to will appear right here. We can see, of course, the same metadata, the dino type and continent, and we can navigate right from here to the dataset itself where it has been found, and we can actually take a look at it. So this makes the complete circle of creating datasets, adding schemas, and being able to search both Dataverse and AROCRate level metadata. So thank you very much. I will now pass the floor to Laszlo, maybe.
So you see that the basic problem with this integration, that those available complex tools are quite heavy and integration. During the integration phase, we didn't want to reprogram those tools, just minimal invasion, minimal development efforts. We try to at least avoid the internal major reformulation of the code. That's why we had to search for such kind of other development types, how to avoid the reprogramming of the tools themselves. The system is currently working more or less, you see, and hopefully the introduction of the system for the Hungarian research community will be smoother, because what we learned that the researchers in our country are not very well trained in this field. Hungary is a bit latecomer in the data repository domain. We had to teach and train researchers to use the system, as well as the basic concepts of the data management are still a problematic part in our environment. But in the longer run, we expect that the Hungarian research will be able to publish their data through the system, and which is normally required by the different journals and conferences currently. Anyway, this was the ARP, a short introduction of the ARP, and we are happy to respond for questions.
Thank you, Laszlo. Yes, so we'd just like to open up to the floor. If anyone does have any questions, please do unmute your microphone, and the team will be happy to address this on the call today or afterwards. If you do have anything else you'd like to add, you're welcome to put that in the chat at this point as well.
At least we are really thankful that you are coming. You were here, because this is not obvious that the Hungarian environment creates a lot of interest in this field. But hopefully, we will, in the longer run, we will be more active in the field.
Yeah, absolutely. I think from my side, what was your biggest challenge of putting this huge piece of work together, Laszlo? And that could be for anyone in the team, really. What was your biggest challenge to put this piece of work together?
The biggest challenge was that in a limited time, within a limited financial framework, you had to produce a production level system. And this is obviously a very difficult development effort. Unfortunately, those tools were quite old and heavy. That's why this approach has some limitations. We cannot,
but overall, we selected tools that provided APIs, first of all, that helps the integrations. And if it was not enough, like in the case of Dataverse, we went deep into it to integrate AROCrate and the AROMA authoring. So that was one where we went deep into it. But in case of CDAR, we just really used the APIs and added some user interface elements to help its integration with Dataverse. But otherwise, yeah, it was more of an integration based development effort.
And don't forget the localization, which was also missing.
Yeah, sure. That's always a problem, because Hungary is not one of the first that gets localizations in this software, so we had to take care of this ourselves as well, right?
But the biggest challenge is how to convince people to use that environment and the different services of the environment, and will be a challenge in the future as well, I guess.
Yeah, absolutely. Certainly an ongoing challenge to get people to use these, to use the technology and continue being a part of this community as well. But Andres, I see you have the shared screen. Would you like to share the demo?
Just as in the circus, you never stop with a failed demo. So I show you that finally it succeeded. That there is one metadata field which doesn't work, but this works here. So if I push the search button, I get this. Of course, this is the single example, but it finds the this water isotope. I don't know how to tell it in English. Okay, thanks.
So thank you very much for your coming, and if there is no question, we can close the session, I guess.
Yeah, I'd like to say thank you for the three of you presenting today. I think it's always interesting to hear different perspectives, different technologies coming across from different communities with different challenges as well. But like you say, localization is an issue that a lot of organizations face as well. So it's great to be able to present that today as well. So yeah, I'd like to say a big thank you to Laszlo, Topolash, and Andres for presenting today. And for those of you in attendance with us today, there is another fair implementation workshop happening next week. It's happening on the 16th. Sorry, in 2 weeks' time, on the 16th, I should say the 16th there. It's going to be about the data champions, exploring the definition, qualities, roles, and responsibilities of a data champion. So again, I'd like to say thank you all for coming and for joining us today. And please do go on the Fair Impact website to see what the next Fair Implementation workshop is that we're going to be presenting. Thank you again.
Thank you.
Thank you. Bye-bye.
Thank you for the
Bye-bye.
discussion. Bye.